So let's look at some numerical examples for the application of the binomial formula. Now consider one call option. The current spot price for the underlying stock is $65. The up proportion is 1.3 and the down proportion is 0.78. The risk-free rate still 8%. The strike price for the call option is $70. And let's see what we can get. If the stock go up after one period, it's 1.3 times 65, we have 84.5. The strike is $70, which means the payoff to the call option in the upstate is 84.5 minus 70, we have 14.5. So let's look at 14.5. This is the upstate. This is the call option in the upstate. In the downstate, we have 0.78 times 65, and that gives us 50.7, which is below the strike price. The call option is out of money. So in the downstate, the call payoff is 0. See D here. You have 0. And then to get the call premium using the binomial formula, what we do is simply apply the risk-neutral probability to this upstate payoff and downstate payoff, and then take the discount, right, at the risk-free rate. So what is the upstate probability? Again, upstate probability is the risk-free rate plus 1 minus the down proportion divided by the distance between the up and the down proportions. So the upstate risk-neutral probability is 0.57692. And then 1 minus P star, the downstate risk-neutral probability is 0.42308. Again, it's P star times the upstate call payoff, 14.5. So 0.57692 times 14.5 plus the downstate probability times what the payoff in the downstate to the call option, which is 0. So this whole thing is 0. And then don't forget the risk-free rate discounting, right? These are future payoffs, so we need to discount those. And then we have a call premium of $7.75 almost, right? 7.74573. Basically $7.75. That's the call premium according to the binomial formula. Now to complete, we basically have here 7.74 and let's see, 573. It's again, this thing come from 1 over 1.08 times basically 14.5 times that 0.5. What's the risk neutral probability here? 57692. 7692. Now, because the downstate payoff is 0, that 0 times any probability number will be 0. So you can actually ignore part of the calculation there. Okay, now we have the call premium, and what we can do next. Here is a situation. If the market price for this call is $9, so basically overpriced, okay? And let's use $10,000 shares on the call options, okay? It's basically 100 call contract. If each contract have 100 underlying shares, it's 100 call contract. So just think about shares, okay, in terms of shares of the underlying. And we can think about using this call option for 10,000 underlying shares to execute an arbitrage. Now remember, the call in the marketplace is overpriced. So we are going to sell the overpriced call in the market, and then we have to hedge ourselves because we have sold the call. We will formulate a long synthetic call using what? Using the delta times S0 plus the borrowing money, the borrowing amount, right, plus B. Now, what is delta? You see, delta is quite easy once we remember our previous picture, right? It's the call payoff difference over the up and down proportion distance. Okay, it's 14.5 minus 0 over 84.5 minus 50.7. These are the numbers we have got, and we have gotten. And delta is 0.42899. If we have 10,000 underlying shares, that means we need to take a long position of 4,290 shares. Okay, round it up. 4,290 shares. That's the long part. And remember, we have to borrow money. Let's see how does it work. First, we sold 10,000 call options, and that or each option for one share, right? That bring in $90,000. $90,000. And then we need to purchase the stock. That's a long position. It's this 4,290 times the underlying price. Where's the underlying price? To start with, it's $65. So we actually need to spend $278,850, this amount of dollars, to purchase the stock. But we don't have that much. Then we need to borrow the money, borrow the rest of the balance. And that is, well, this $278,000 something minus the $90,000 we bring in from selling the car. So we need to actually borrow $188,850. Okay, now that's our synthetic long call. What we need to see is after one period, right? My long synthetic call can cancel the payoff in the short call I've written, and then there should be some profit for us because we have sold an overpriced call. Okay, so let's see. In the upstate, the underlying price become 84.5, and we have 4,290 shares. Right, those are the from the long position, and the call is in the money. The call is in the money. So the long party will execute that. Will exercise that long call, right? But we have shorted it, so we need to pay It's 14.5 times 10,000. Okay. And after that, what is left for us is $217,505. That's in the upstate. In the downstate, the long position become 4,290 times 50.7. That's from the long underlying stock position. And the call is out of money, so there's no liability from our short calls. And this product is still about the same. It's $217,503. Okay, only $2 difference. Roughly not the same, just due to the rounding error. The initial investment amount, if we haven't borrowed $188,000 something, okay, is this number. So if we have put in our own money instead of borrowing, right, what kind of return we have is 217,505 over 188,850. Okay, minus 1, we get the percentage profit or percentage return. That is 15.173%, which is higher than the risk-free rate. So if we borrowed this $188,850, okay, if we have borrowed this amount, set up the synthetic long call at 8%, then basically we can take the interest cost out and look at $13,547 in net profit. This is the arbitrage profit. It's a risk-free profit. Now let's look at applying the binomial formula to a put option. Instead of considering a $70 strike call, let's look at a $70 strike put. Now, in the upstate, we know the upstate price is 84.5, which is above $70, so the put is out of money. In the downstate, the put payoff is $70, the strike, minus this downstate price, 50.7. So that's 19.3. Okay, the upstate payoff, downstate payoff for the put option. So let's write that down. The upstate for the put option is 0. The downstate, right, this is the put option payoff in the upstate. I think 19.3 is the put option payoff in the downstate. So we are interested in here. Right? This one is what? Again, risk-free discounting times what? Actually now we know the upstate payoff is 0, so it doesn't matter what its probability is attached to, it's 0. So it's 19.3 times the downstate probability, 0.42308. 0.42308. Okay. And just calculate that number, we can have 7.5606. So 7.5606. So that's the put option premium for a $70 strike put for this underlying now has a $65 spot price and $65 spot price, up proportion 1.3, down proportion 0.78, with risk-free rate 8%. So that's again the risk neutral probability, right? It's the same for both put and calls because it doesn't really depend on those. And we always use the upstate probability times the upstate payoff for the option, and downstate probability times the downstate payoff for some option. As long as it's for the same option and you get the upstate and downstate payoffs in the correct place, there's no change in the application of the formula itself. Okay. All that we have changed are these payoffs, right? For calls, right? Upstate 14.5, downstate 0. For the put, upstate 0, downstate 19.3. Okay, always discounted using the risk-free rate, but the fact is that as long as it's an option, right, that particular risk-neutral probability will attach to the payoff in that state. Okay, how about two periods? We can look at a underlying, do not just go for one period, but for two periods. And what we will not change is the upstate and downstate proportions. Okay, we won't change that. So what we are thinking is this: if you go up from 65, go up once, and then go up twice. The second time will be, let's see, 1.3 squared. Okay, 1.3 squared, and also from this up point it can go down. 0.78 times 1.3, and or it's if it come from this upper branch, right? It's 1.3 times 0.78. Here in the down branch is 0.78 times 1.3, but then both are of the same value. In the double down state, right? Go down once, go down twice. It's 0.78 squared times 65 as 0. In each of the ending nodes, right, ending node, we can calculate the payoff for the call option. Right? Now the assumption is that this call option will expire 2 periods later, right? Have a life or maturity of 2 periods. Once these values are available, it can be, this is a positive number and the other two are both 0, or one positive number, another smaller positive number, and 0 in the double down state, right? It depends on. But once these payoffs are determined, we can apply the binomial formula backwards along the tree. So from the double up payoff and up down payoff, we can calculate using the binomial formula the upstate call option price. And using the up down payoff and the double down payoff to the call option, applying again the binomial formula, right, from these two nodes, going back to the down state in the first period, we can calculate the call option price in the down state in the first period. And then we go backward once again from the upstate call price and the downstate call price. We calculate the call premium at the beginning of the period, okay, at date 0 or time 0. We can going backwards and do our calculation. That's so-called backward induction. We just keep going back along the tree. Up, 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 down, going to up. And up, down, 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 going to down. all right, and then up and down going back to time zero. The basic assumption allow us to do this is that for each time period we have the same up and down proportions, and then that means we can apply the same risk neutral probability for every period. So for each period we just apply the binomial formula again and again, and going backwards along the tree. All right, let's look at we have talked about all this calculation. Along the different nodes, right? Either here, right? In the upstate, in the first period, or downstate in the first period, or initial at time zero, we actually have different deltas. But you can see that these deltas, right, in the upstate, downstate, period zero, time zero, right, it's always the difference between the call payoffs over the difference between the two states underlying price. It's always that. That's how we get the delta. And obviously, the delta itself will change. Okay, once one period passed, right, there will be either the upstate or downstate is realized. Then you actually have a new delta for the call option or any option you have. Then if you want to hedge that option, you actually need to adjust the hedging according to the new delta. So that's so-called dynamic delta hedging, which is one important topic we will explain in chapter 12, in the lecture 12. All right, now we have a different set of numbers. We have an underlying of $30, and the call option is at the money. Right? Strike is $30. Upstate 1.14, downstate 0.89. The risk-free rate is 3%. So in the upstate for the stock price, underlying price, going up once it's 34.2, going down once 26.7, going up twice 38.988, going up and down is 30.438, going down twice 23.769. Okay, so we have three different underlying prices in the three different ending states after two periods. Okay, after two periods you have up, down, and down, right? Three different states, three different underlying prices, and three different payoffs. Because we have a $30 strike, it takes 30 out of all these underlying price at the end of the second period, except the last one. The last one is below 30, so the call is out of money. So put 0 for the down state. Let's go to this. The last one is 0. Right? In the middle, what do we have? We have 30.438 minus 30, so 0.438. So this is 0.438. And in the upstate, we have 38.988 minus $30, the strike. So it's 8.988. $8.98 Okay. So that's our call payoffs in three different states. And what we are interested in will be, all right, what's the number here for the call options upstate price, or how much it's worth. And then in the downstate, how much it's worth. And then using these two numbers we haven't got yet to calculate the initial call premium. Let's look at that. Again, to use the binomial formula, we will first have to calculate the risk neutral probability, which based on the up and down proportion and the risk-free rate. So the upstate risk neutral probability is the risk-free rate minus the downstate proportion, right? 1.03 minus 0.89 divided by the distance between the up-down proportions is 1.14 minus 0.89. We got 0.56. And downstate risk neutral probability is 0.44. All right. Now we can apply the binomial formula. Okay. 0.56 times 8.988 plus 0.44 times 0.438. Right. This is the risk neutral expected value. Then because it's a future value, bring it down one period 1.03, okay, by the risk-free rate. And the upstate call option price will be 5.07379. So we get 5.07379. And let's look at the downstate. Right? It is now we apply. Okay, apply 0.56, 0.44. Right, here's 0.44, 0.56. Okay. Then we have, again, apply that to the up down and then down state. Right? We have the call value in the down state about 24 cents, 0.23814. 0.23814. Still, the risk neutral probability when we work back along the binomial tree doesn't change, so we again apply these two risk neutral probability with respect to the upstate call value and the downstate call value. Let's see. That's in the next page. And don't forget to use the risk-free rate to discount these values. And we have 0.8603. So here's the 2.8603. 2.8603. Okay, this is how we can apply the binomial formula working backwards along the binomial tree to get, from these three values. Right? We first get the two call option values in the up and down states, and then finally we go back one period further to get the time zero call value, which is 2.8603. That's the premium we can get in this two-period binomial model. Now that we have all the call values, and we've also discussed the calculation of the deltas. If you go back, right, we can have different delta values at different nodes. on this picture, right? At time 0, and then let me see, time 0, then time 1, there's upstate, time 2, time 1 downstate. Okay, at these 3 nodes along the tree, we can have different delta values. And then we can think about this question. If you have long calls and you can use short underlying positions to achieve a risk-free hedge. In other words, combining a long call and a short underlying position, we will achieve a position that only evolve at the risk-free rate. Here, we want to examine 2 points. One is at time 0. The other is in the after the first period, in the downstate. That's this point here and the downstate, right? In the after the first period in the downstate. Okay, so at time 0, what do we have? Is 2 call values, right? In the upstate, 5.074, and the downstate, 23 cents and 8. So that's the difference between the call values, and we know the denominator is the distance between the 2 up and down proportions times the spot price, the current underlying price at time 0. This is basically the up and down underlying price difference. So that is 0.6448. Think about 10,000 shares, okay, in the underlying. Then that's 6,448 shares. So basically, at time 0, if I want to achieve a risk-free portfolio, if I have 10,000 calls, right, then I need to short 6,448 shares of the underlying. Now, at the first period downstate, at this point, what we have is the 2 value, right, in the down up is 43 cents and 8, and the down is 0. So in the numerator is 43 cents and 8 minus 0, and in the denominator, it's still this difference between the 2 up and down portions, but now this price, right, is the underlying price in the downstate after the first period, which is, let's see, $30 times 0.89, 26.7. So that's the downstate delta. It's a different delta, which means still for the same 10,000 calls, right? Now to achieve risk-free hedge, we only need to sell 656 shares. That's this delta 0.06562, right? Times 10,000. Only need to have a short position of 656 shares in order to hedge my 10,000 long call, just because it's getting closer to out of money. Value has decreased. So let's look at what do we have in our Excel model. We have the numbers here. The initial call value 2.8603, right? That's the call value here, and this 10,000 is for the call positions underlying shares. Also, it's the base, right? To achieve this delta hedging, the underlying spot price at time zero is $30. Delta is 0.68, 0.6448. And what's this? This is you have a long position in the call, right? This is the blue, 2.86 times 10,000. That's the long position. That's the value of the call. And then we are going to short. We're going to short the purple, and delta times 30 times this 10,000. Okay. So if you think about the long cost assets and then the short positions as liabilities, right, we have a net liability of 164,840. But if you think about cash flow, what happened is basically we shorted 6,400 something shares at $30 per share, and then we used part of the proceeds bought the long call, right? 10,000 long call. And basically this negative number, though, it shows a liability, and it's money coming in, okay, from the shorting position minus the long call cost. That's money coming in. And what we are going to see is that this amount of money doesn't matter whether the underlying go up or down after one period, okay? It will evolve at the risk-free rate. It will evolve at the risk-free rate. So now think about this amount of money as cash inflow, and then you deposit this cash inflow at the risk-free rate. And after one period, this liability position will evolve at a risk-free rate. So your cash position grow at a risk-free rate, your liability grow at a risk-free rate, you end up have no net liability. That's why it's a hedged position. Okay, let's look at what will happen if the underlying price going up. That is moving from $30 to 34.2. And we know when that went up, the call value become 5.074. That's what we have calculated. Okay, that's what we have calculated. And still we have this 10,000 and 10,000 in the long call covered underlying shares, and we have a shorted, right, 6,448 shares of the underlying. And look at this net position. Okay, this net position. What I have done is just put the call premium and delta is the green one, and times the purple, which is the underlying price. Okay, everything scaled by F9, which is the 10,000. So this is the net liability position. This is the liability position. Okay. All right. And let's see how much the liability has grown. This blue number divided by our old liability minus 1, which is give you exactly 3%. Okay. Now this liability again can be paid if you have deposited this cash inflow at 3%. So it's completely hedged, risk-free position. In the down state, we have the same story basically. You have, yes, we have a new value in the underlying 26.7, and let's see, in the down state, right, you have 23.8, cents. This is the call value in the down state. Delta is still the 0.6448. Same calculation, right? Your long call minus the short in the liability, and this number has grown at 3%. Okay, 3%. So that is actually somewhat a strange hedging because you hedge the long call, right? Use the short underlying position, hedge the long call. Usually when we think about hedging for call position, we will think about from a dealer's view. That's the dealer has written the call, and then the dealer will need to buy the underlying to hedge their written call exposure. Okay, that is at this initial node, right? At the beginning time 0 here. And then we also want to know how the delta hedge performed in the down state after the first period. So let's look at that. Now in the down state, right, we have basically this set of numbers carried over. But now the delta is different. Delta is no longer 0.6448. Delta is 0.06562. And then still we use this 10,000, right, times the call value and the short underlying at 26.7 times the 10,000 times the delta. That's the new liability, right? Significantly reduced. Still, if you think about the cash position, that can still be invested at the risk-free rate, 3%. And the point is that this liability will grow at 3% after the second period. The stock go down or up again because it's a completely delta hedged position. This liability only grow at 3%. Now in the upstate, right, going down and then up, the call become 43 cents, 0.8, and the stock value is 30.438. Still we have this delta and the number of shares in the option, and then we can calculate this liability position. Same calculation as before, right? Call minus the underlying price times delta, and everything adjusted using the brown one, right? The 10,000. Again, look at how this position has evolved, 3%. That's for the down up state. And in the down state, right? In the down state, call is out of money. The stock share has declined to $23.76 and 3. Delta is the same, still 0.06. Right? Basically after period 1, we have a smaller delta, so we adjusted the underlying shares, right? The number of underlying shares that we are holding short. We have adjusted that. That will go into the end of the second period. And still, this is the new liability position, same number as above, as this one. The change is still 3%. Okay, so let's think in very simple term, right? After one period, you can use the cash inflow grow at 3% to pay off the liability, right? And you can say you kind of clean out every position, both the long call and the short underlying. And then after that, in the down state, you formulate another one, right? Acquired this long call and shorted the underlying at 26.7, but the ratio is this much smaller delta, even basically 10 times smaller. And this liability or cash inflow, right, can still grow at 3%. If you deposit again this cash inflow at 3%, it will be able to pay off this liability at the end of the second period. And it's completely risk-free.